Hello, in this video I am going to talk about current divider rule. Current divider is how current is distributed between different resistors connected in parallel. To understand current divider rule, it is helpful, as usual, to use the water analogy. Here we have a bucket full of water that when released will allow the water to flow through the pipes and into the empty buckets below. The difference between them being that the left-hand pipe is thin while the right-hand pipe has a larger diameter. The pipes can be considered resistors to the flow of water, with the smaller the diameter, the larger the resistance. As the water flows, more will go through the larger pipe, meaning that the right-hand bucket will have more water in it at the end. By taking away the buckets and changing the pipes into a large and small resistor, the system can then be set up into a circuit. The red arrows represent current through the circuit and shows how the smaller the resistance, the greater the share of the input current. The electrical current can be considered the same as the water flowing through the pipe from before, where the higher the resistance, the less will go through. The current divider rule is useful when the voltage is unknown, but you know the source current. So to actually analyze this circuit, the total parallel resistance needs to be calculated. From here, the current through the resistors can be calculated by this equation, which means that the current will split with a ratio equal to the inverse of their resistance values. RT is the total parallel resistance of all the resistors. Subbing these values into the equation, we get I1 being 11.9 milliamps and I2 being 1.19 amps. There is also a special case for current divider rule, which is when there is only two resistors in parallel, and this means that these new equations can be used. It should be noted that the opposite resistor to the side being measured is on the numerator of the new equation. Then after subbing the values in, you can see that these results are the same as previously calculated. This special case is useful because often in a circuit analysis, there is only two resistors in parallel, and by using this equation, you can get the answer much quicker as you don't need to calculate the parallel resistance first. By considering the water analogy, you are able to estimate a value in your head before attempting a problem by knowing that there should be less current through the larger resistor. Therefore, if you get an answer that does not go with your estimate, you can go back and see where you went wrong, often using the wrong resistor value in the numerator. Current divider is a useful equation in the analysis of circuits and can be used to solve both AC and DC circuits. Thanks for watching.